Good day to you, children. In the last class we learned a theorem that stated that vertically opposite angles are equal. So also we solved several solved examples from your textbook, and your homework in that class was to solve the first main from exercise 3.1. So in today's class I'll begin with the second question from exercise 3.1. In the second question, in figure, lines XY and MN intersect at O. So here look at the figure. Lines XY and MN intersect at point O. If angle POY is equal to 90 degrees, it is this angle POY is equal to 90 degrees, and A is to B, that is angle A is to B is 2:3. Find the value of angle C. So solution: given XY intersects MN at O, this is given to us, and angle POY is equal to 90 degrees. Moreover, A is to B is equal to 2:3, that is the ratios between the angles A and B is 2:3. This is similar to the problem which we solved in the solved examples. So now the solution, we have to find angle C. To find angle C, first look at ray OP and OM. Ray OP and OM stand on the line XY, so they form a linear pair here. So in our solution, first let us write angle POY plus A plus B. A and B are the angles POM and MOX, okay, is equal to 180 degrees because they are linear pair. So now we know that angle POY is 90 degrees. This implies 90 degrees plus A plus B is equal to 180 degrees. So this implies A plus B is equal to 180 degrees minus 90 degrees. This implies angle A plus B is equal to 90 degrees. This is our first equation. Now let's make use of the ratio. From the ratio, from the ratio 2:3, we get 2 plus 3 is equal to 5. So now let's convert the ratio into fractions. Therefore, A is equal to, what is the corresponding ratio? The corresponding number in the ratio to A is 2. So 2 by 5 into 90 degrees from 1. From 1, because A plus B is equal to 90 degrees. So into 90 degrees. 5 ones are 8. This implies A is equal to 36 degrees. Similarly, B is equal to, now the corresponding number in the ratio to B is 3. So B is equal to 3 by 5 into 90 degrees. 5 ones are 5 18s are. So this implies B is equal to 18 3s are 54 degrees. These are the values of our A and B. Now if you look here, if you look at the figure, then MN is a line and OX is the ray standing on it. Neglecting this whole right part, MN is the line and OX is the ray standing on top of it. So angle B and C form a linear pair. So you make use of this information to find the value of B. So write down ray OX stands on line MN. Therefore, B plus C is equal to 180 degrees, which is a linear pair. Name this as equation 2 and this be equation 3. So now we get this implies 54 degrees plus C is equal to 180 degrees from equation 3. From result 3 we got B is equal to 54 degrees. So C is equal to 180 minus 54, which is C is equal to 126 degrees. This is our solution. So, in question number 3, in figure, angle PQR is equal to angle PRQ. Then prove that angle PQS, that is this angle PQS is equal to angle PRT. We have to prove this angle is equal to this angle PRT. And we have angle PQR. This angle is equal to angle PRQ. So solution. First let us write given angle PQR is equal to angle PRQ. This is given to us. So now QP stands on ST, right? This line segment QP stands on the line ST. So it forms a linear pair with angle PQR and angle PQS. So therefore angle PQR plus angle PQS is equal to 180 degrees. This is our equation 1, because they are a linear pair. Similarly, PR stands on ST and it forms a linear pair with angles PRT and angle PRQ. So we can write PR stands on line ST. Therefore, angle PRQ plus angle PRT is equal to 180 degrees. This is equation 2, and the reason is that they are linear pair. So now subtract equations 1 and 2. Either you can subtract them or from Euclid's first axiom, that is both the equations are equal to 180 degrees. When things are equal to the same things, they are equal to one another. We can directly equate them and cancel. Otherwise, subtract equations 1 and 2. What do we get? Angle PQR plus angle PQS is equal to 180 degrees minus angle PRQ. We here plus, it will become minus angle PRT is equal to 180 degrees minus. So 180 minus 180, we will get a 0 here. Angle PQR, we know that angle PQR is equal to angle PRQ. So this cancels out. Now we have angle PQS minus angle PRT. So write it down. Angle PQS minus angle PRT is what is remaining. This implies angle PQS. When I transpose this minus PRT to the right hand side of the equation, minus becomes plus. We will get PQS is equal to PRT. So we were supposed to prove angle PQS is equal to angle PRT, and on subtraction and simplification, simplifying the whole thing, we got angle PQS is equal to angle PRT. This is the required solution. So in question 4, in figure, if x plus y, that is angles x plus angle y, is equal to angle z plus angle w, then we have to prove that AOB is a line. Please note angle, sorry. We have to show that AOB is a straight line. So when do we say to prove that AOB is a line, we have to show that sum of either of these angles, that is x plus y or z plus w, is equal to 180 degrees, because whenever two adjacent angles, these are adjacent angles, right, they share a common arm and a common vertex. So when two adjacent angles have a sum of 180 degrees, then their non-common arms form a straight line. That is the inverse of the linear pair axiom. So now solution: given x plus y is equal to z plus w. This is given to us. Now we know that look here, x, y, z and w all are the angles at surrounding a common point O, and when angles are surrounding or angles are around a single point O, their sum is always equal to 360 degrees. They are also known as angles around a point. We know that x, y, z and w are angles around a point. Therefore, x plus y plus z plus w is equal to 360 degrees. This is the equation 1. But we know that x plus y is equal to z plus w. So here I can replace z plus w by x plus y. So this implies x plus y plus x plus y is equal to 360 degrees, because it is given to us, because we know that their sums are equal. So now x plus x, 2x plus y plus y, 2y, it is equal to 360 degrees. This implies 2 times, I took 2 common, 2 times x plus y is equal to 360 degrees. Now this implies x plus y is equal to, since 2 is multiplied here, if I transfer it to the other side of the equation, it will be divided, 360 by 2. 2 ones are 18s are 180s are. This implies x plus y is equal to 180 degrees, which is equal to z plus w. This is our required result, since the sum of adjacent angles is 180 degrees, AOB is a straight line. This is our solution. In the 5th question, in figure, POQ is a line, ray OR is perpendicular to line PQ. Perpendicular means ray OR makes an angle of 90 degrees with the line PQ. If OS is another ray lying between OP and OR, prove that angle ROS, that is this angle, is equal to half of angle QOS minus POS. So we are supposed to prove that angle ROS is half of angle QOS minus angle POS. The only information that we have is that PQ is a line and angle ROQ and angle ROP is equal to 90 degrees. So now first solution. Given PQ is a line with OR perpendicular to PQ. This is what is given to us. This implies angle ROQ is equal to 90 degrees. Also, angle ROP plus angle ROQ is equal to 180 degrees because they are a linear pair. This implies angle ROP plus 90 degrees is equal to 180 degrees. On simplification, we get angle ROP is equal to 90 degrees. This is our equation 1. If you look at the figure, then you see that angle ROP is made of two angles. We can write angle ROP is equal to angle ROS plus angle SOP. So angle ROP is made of these two angles. We know that ROP is equal to 90 degrees, which is equal to angle ROS plus angle POS, SOP or POS. Both are one and the same. This implies on rearranging we get angle ROS is equal to 90 degrees minus angle POS. This is equation 2. Similarly, angle QOS is also made of two angles. So we can write angle QOS is equal to angle ROQ plus angle ROS. We know that angle ROQ is 90 degrees. So angle QOS is equal to 90 degrees plus angle ROS. So on rearranging we get angle ROS is equal to angle QOS minus 90 degrees. This is our equation 3. Now adding 2 and 3 we get angle ROS plus angle ROS. Okay, LHS both are ROS is equal to 90 degrees minus angle POS plus angle QOS minus 90 degrees. That is the RHS of equations 2 and 3. So 90 degrees minus 90 degrees cancel each other. ROS plus ROS is 2 angle ROS, which is equal to, on rearranging these two, get angle QOS minus angle POS. So this implies angle ROS is equal to half of, transposing 2 to the other side, we get 1 by 2. Half of angle QOS minus angle POS. This was our required result, that is angle ROS is equal to half of angle QOS minus angle POS. In the last question, that is the 6th question, it is given that angle XYZ is equal to 64 degrees and XY is produced to point P. Draw a figure from the given information. So first let us draw the figure. So we have an angle which is XYZ, which is named XYZ, and it measures 64 degrees. So Let this be our angle X, Y and Z, which measures 64 degrees. Moving ahead, they also say that XY is produced to point P. So we have to extend XY to some point P here. So let's do that. Producing XY to some point P. Since I am producing them, I am using dotted lines. Producing XY to point P. Also, there is a ray YQ, that is, the ray originates from Y and goes up to point Q. This is the ray YQ, which bisects the angle ZYP. It bisects this whole angle ZYP into two equal parts. It is an angle bisector. We have to find angle XYQ, the value of this angle XYQ, and also the reflex angle QYP. If to find the reflex angle, this is the reflex angle QYP from point Q, point on ray Q to some point on ray P. So let's start working out through our problem now. So we know that in solution, first let us write down given angle XYZ is equal to 64 degrees. This is given to us. So, and PY X is a straight line. Therefore, angle ZYP plus angle XYZ is equal to 180 degrees because they are a linear pair. This implies angle ZYP plus 64 degrees is equal to 180 degrees because it is given to us. We know that angle XYZ is 64 degrees. So this implies angle ZYP is equal to 180 degrees minus 64 degrees. So solving it, we get 7 minus 6, 116 degrees. Angle ZYP is equal to 116 degrees. This is our equation 1. We are supposed to find angle XYQ, this angle XYQ, from this information first. So we also know that YQ is an angle bisector because they say that they have told us that YQ divides the angle ZYP into two equal parts. So YQ is an angle bisector. This implies angle ZYQ is equal to angle QYP, which is equal to half of angle ZYP. So half of angle ZYP will be how much? Half into 116 degrees. This implies angle ZYQ is equal to angle QYP is equal to 2 1s are 2 5s are 8s are 58 degrees. This is our equation 2. So now we know that angle XYQ is equal to angle XYZ plus angle ZYQ. We know that angle XYZ is 64 degrees plus angle ZYQ. Here from result 2 we got angle ZYQ is equal to 58 degrees from equation 2. So on adding we get angle XYQ is equal to 8 plus 4 12, 1, 6 plus 5 11, 12, 112 degrees. This is our first result. To find reflex angle QIP, all we have to do is subtract angle QIP from 360 degrees. So 360 degrees minus angle QIP. You know that angle QIP is equal to 58 degrees. So reflex angle QIP is equal to 360 degrees minus 58 degrees. From once again we got the values from equation 2. So reflex angle QYP is equal to QYP is equal to 302 degrees. This is the required solution for the given question. So this completes your exercise 3.1. In the next class we will begin with parallel lines and transversal. Thank you.